Hello everyone, welcome back to my YouTube channel Learning with Deepu. In today's video, I will be discussing the M4 concepts, function composition and inverse functions, an exploration of key concepts in discrete mathematics. Myself, Deepu ji, and let's begin for more introduction. In this presentation, we delve into the fundamental concepts of function composition and inverse functions, detailing their definitions, properties, and applications in discrete mathematics. Let's move on to function composition, definition, and basic concepts. Function composition involves combining two functions where the output is one function becomes the input to the other. If f of x and g of x are two functions, composition is denoted as f of g of x is equal to f of g of x. This operation is fundamental in various mathematical contexts, allowing the analysis of multi-step processes. Properties of composition. Function composition is associative such that f of g of h is equal to f of g of h. However, composition is generally not commutative, meaning f of g may not equal of g of f. Understanding these properties is crucial for manipulating and simplifying complex functions. Example in discrete mathematics. In discrete mathematics, function composition can be applied to sequences, transformations, and graph theory. For instance, combining transformations of various vertices in graph can model different scenarios in network analysis. Let's move to inverse functions. An inverse function essentially reverses the effect of original function. If f is a function, its inverse denoted as f of to the power minus 1 satisfy the condition f of f inverse of x is equal to x for all x in the function's range. This is crucial for solving equations and understanding functional relationships. Finding inverses algebraically. To find the inverse of a function algebraically, one typically swaps the input and output values in the equation and solve for the output. Ensuring that a function is one-to-one bijective is necessary for the existence of an inverse, which can be verified using horizontal line test. Graphical interpretation of inverses. Graphical interpretation of inverses function involves reflecting the graph of a function over the line y is equal to x. This reflection highlights the input-output relationship and demonstrates how for each output the original function there is a corresponding input in its inverse. The visual method enhances understanding the function relationships and the applications. Real world examples. Function composition and inversions have practical application in fields such as economics, whereas function may represent cost transformations, or in biology, where population models can be represented with functions. Understanding these functions always allows professionals to predict the outcomes to make informed decisions. Used in computer science. In computer science, function composition can streamline processes through modular programming, where functions are combined to create complex behaviors from simpler ones. Additionally, algorithms often utilize inverse functions for tasks such as undo operations, enhancing user experience in software applications. Connections to other math concepts. Function composition and inverse relate closely to other mathematical complexes like relations, graph theory, and algebra. They form the basis for more complex operations, including transformations in linear algebra and the applications of functions in calculus, where continuity and differentiability are examined. Common misconceptions. Confusing in composition with inversion. One common misconception is treating function composition as the same as finding inverse. While composition involves combining functions, inversion is about reversing their effects. Recognizing this distinction is vital for accurate function manipulation and application. Conclusion. In understanding function composition and inverse functions is crucial in discrete mathematics and various applications across disciplines. Their properties, graphical interpretations, and relationships to fundamental mathematical concepts underpin many analytical techniques. Recognizing and addressing uncommon or common misconception will enhance clarity and accuracy in mathematics related tasks. Thank you. Thank you for watching my video. Do like, share and subscribe.